Hello, welcome to acceleration in physical science. Now, what do we mean by acceleration? Acceleration is the rate at which an object changes its velocity. So we've already done velocity, we should have a good idea about that. And so velocity doesn't have to be constant, it can change, and acceleration is a measure of the rate of that change. Now, deceleration is of course a negative acceleration when an object is slowing down, when its velocity is decreasing. Now, generally the formula for acceleration is just change in velocity divided by time, and that's written as delta v, where delta in the Greek alphabet means changing. So change in velocity divided by change in time. And in words, we would have final velocity minus initial velocity, because that's how we measure the change in velocity, divided by the time taken. Now, in terms of formulas or letters that we assign in physics, A is acceleration, V is final velocity, U is initial velocity, and T is time. Now, the units for acceleration are typically meters per second to the minus 2. Now, don't get too confused by that minus 2. That's just because the velocity is itself in meters per second. And so because we've got a change in time, it becomes meters per second to the minus 2. The simplest way most students get around it is whenever they're working out an acceleration, they just need to put a minus 2 there and make themselves remember it. So U is the initial velocity, V is final velocity, and T is of time. Now, we can rearrange this formula, which is A equals V minus U divided by T, and we can solve it for any of those things. And here they are rearranged, so we can use this equation rearranged to solve for V, U, or T, and hopefully in your maths classes you're learning how to do that, so you can do it already. It's because it's handy. The other way, if you're not great at rearranging formulas, is just to use this equation which is given on your sheet. I think it's given in this form, but make sure that you put the numbers in and then you simplify as much as you can by using the numbers. Now, on your information sheet, this is what you have. Don't worry about these guys and these guys. These are all called the equations of motion, which we'll be using later on when we do the equations of motion. But I just thought I'd introduce you because you're going to have to get used to using these letters U, V, A, S and T in this section, and then you're going to be using them a great deal more in the next section when we do physics. But there's our equation that we were mentioning before, just rearranged to solve for V. So let's have a go at an example. A car initially travelling at 10 meters per second is found to be travelling at 20 meters per second in the same direction 6 seconds later. What is the car's average acceleration over this time? So I often find that it's a good idea to, when you're starting off these things, just to circle the information that you're given. And the first piece of information is a velocity, and then we're given another velocity, then we're given a time, and we're asked to find the acceleration. So the next thing you try and do is assign letters to the information that you're given, and sometimes you have to read the question carefully if it's a word question to actually assign different letters. And the letters we're trying to assign are U, V, A, S and T, where U is the initial velocity, V is final, A is acceleration, S is displacement, T is time. So reading this, you'd recognize that here you're given U, here you're given V, and here you're given T. And so we have an equation that relates U, V, A and T, and we can use that equation. Let's see how they do it. And the equation that they're using is A equals V minus U on T. and because the velocities are in meters per second to the -1 and time is in seconds, we're going to get our unit here in meters per second. Now they've just done again 22 minus 10 divided by 6, and your answer is 2 meters per second to the -2. Fairly straightforward. Now let's do a little bit different one. In this case, a truck is travelling down a straight stretch of road at 20 meters per second. It brakes. So in this case, we're going to deal with deceleration. Takes over 5 seconds, it brakes, and it reduces its speed to 12 meters per second. What's its average acceleration? So let's get some idea about what we're given. So we're given those three things, and we've got to find this. What are we actually given? It's travelling down the road at this speed, so we have to read the question carefully. That will be our u, this is our t, and this is our v. Now it's important that we don't mix u and v around, otherwise we'll get completely the wrong answer. Now how do they do it? Let's have a look. And again, they're using a equals v minus u on t because they're asked for a. And notice here that they've assigned each of the characteristics to the letter, what we've done up here. But when you do 12 minus 20, you get -8 as the change in velocity. Delta v equals -8 meters per second to the -1, and that's just saying that it's slowed down. And because it's slowed down over 5 seconds, we then divide that and we get a minus value, and so that's a deceleration. So we're slowing down. Okay, hopefully we're not too confused by that. So generally speaking, if we're getting faster, the acceleration will be positive. If we're getting slower, the acceleration will be negative. In the next video, we're actually going to look at velocity time graphs, and we're going to tie in a little bit of acceleration into those graphs as well. See ya.